welcome to True Projects. In this video, we are going to explain about the project, which is an efficient and robust approach using inductive transfer-based ensemble deep neural network for kidney stone detection. Before getting into the execution, first let us understand what is the project about. And we all are familiar with the term kidney disease, right? Kidney disease is like kidney stones. They are the big health issue all over the world that affects all age groups. It does not belong to respective age, one particular age group. It will also affect all the types of age groups, no matter the age. So it is really important to catch these problems early, because if it is left untreated, they can lead to more serious conditions like chronic kidney disease. But here the challenge is there are more and more number of patients and not enough nephrologists. Here the challenge is there are more number of patients and there are not enough nephrologists, especially in developing countries, which makes it difficult to diagnose and treat people on time. So traditional methods like CT scans, MRI, and also the ultrasounds are often time consuming. So they take so much time to diagnose disease and they can lead to mistakes, causing delays in diagnosis. Another issue is the creation of labeled data sets for training deep learning models in medical imaging. This is not only expensive but also requires lot of expertise, which makes it harder to use these advanced technologies on larger scale. Here where automated diagnostic solutions comes into the picture. They can really help to tackle some of these challenges. They are designed to improve the accuracy and also take some of the pressure of the healthcare professionals. So they don't have to rely as much on manual interpretation. With these systems, the chances of human error are reduced and the results become more reliable and also consistent. This project really emphasizes how important it is to use advanced technologies like these to fix the problems with the current kidney stone detection methods, making sure healthcare providers get the right support when they need it quickly and accurately. Moving on to the proposed system. So, the system we are working on will automate the kidney stone detection using CT images. To get started, we have used two data sets of high quality. So we have used two data sets, one with high quality images. And before feeding them into the model, we apply some pre-processing steps like image augmentation. We apply image augmentation technique and also brightness enhancements. We enhance the brightness of the image to make the images clear and improve the overall quality. And then we extract important features from the images using the pre-trained DNN models. So we extract important features from these images using pre-trained deep learning models like Darknet 19, Inception V3, and ResNet 101. Once we have these features, we combine them into a one big feature vector by concatenating them, which will allow us to take advantage of the strengths of each individual model and improve the system's performance. So we will be combining all these three models into one particular model. To make the system more efficient, we use a method called iterative relief method to pick out the most important features. So this will help us in selecting important features. And this helps to reduce the amount of data we need to process, which in turn speeds up the system without losing any key information. Once we selected those features, we use KNN imputer, that is K nearest neighbor. So this model to classify them. To make sure the model is reliable and performs well, we evaluate it using tenfold cross validation technique, which is essentially test the model in multiple ways to confirm its accuracy and stability. Moving on to the extension part, to further improve the accuracy, we are incorporating the exception model to analyze the dataset. So this model helps to improve our ability to detect kidney stones more accurately. On top of that, we also used YOLO algorithm, that is different versions of the YOLO, to do the detection of the kidney stone, where that particular kidney stone in the image. This is the extension part. So this is great at detecting abnormalities like kidney stones, boosting the overall detection performance. To make sure that system is more practical for the real world use. So here we are not using for real world, but here we are using for testing purpose. So we have built front end using Flash framework. So we have used Flash framework for building the front end. This allows users to interact with the system easily, and we also added user authentication to ensure secure access, making the entire process smoother and safer for healthcare providers. On to the implementation of the project, we have followed different set of steps for classification of kidney stone and also detection of kidney stone. So first, let us understand the steps what have been followed for doing the classification. So what we did is we started by importing all the necessary libraries and packages for image processing and model training. Then we have loaded the CT kidney dataset to understand the structure. And then we apply various transformations. So here we have done rescaling, we followed shear transformation, we zoomed in the images, zoomed in, zoom out, and we also flipped the images into horizontal format. We have reshaped the image. We have converted the image color, that is image format, from BGR to RGB, and we appended all the image to their respective labels, and we have converted all the images to NumPy array format. And then we extracted key features from the images to help the model better understand the data. And moving on, we use early stopping during training to prevent overfitting or underfitting by halting the training when the model performance stops improving. And we set up the model architecture using a predefined structure. Then the model is trained using the processed data to classify kidney stones. Then the best performing model is saved for future use in the kidney stone classification. So this is the classification structure that we have followed to classify the kidney stones. Moving on to the detection part, similar to classification, also in the detection, we have imported the necessary libraries of detection tasks. Then we load the data set, we load and visualize the data set to understand it better. And then we do basic image processing where we convert image to blob format, and we define the classes. That means we define each class for the label, and then we draw bounding box. Then we convert image to NumPy array format. Then we load pre-trained models. Here we will be loading pre-trained models, and then network layers are extracted. Then again, basic image processing is done where we append the image with the annotation file where we convert BGR format to RGB color scale, that is, and we create mask, we resize the image. And we apply basic transformations, random transformations like rotation and resize to the images to increase data variety. It's variety, okay? And then we install any additional packages required for detection. Then the YOLO family models are used to process the images for detecting abnormalities, that is, detecting kidney stones. And here the model is built specifically for the kidney stone detection. And the train model is used using the pre-processed data to detect kidney abnormalities. So we will be using the train model for detecting the kidney abnormalities so that it will get trained to detect the abnormalities. And the best version of the YOLO, that is best YOLO version, will be saved for the future use in the detection of kidney stones. So this is the detection part. Moving on to the front end. In the front end, for building the front end, we have used Flash framework, which includes user registration and login features with SQLite database support. And coming to the next step, that is users, they will be able to upload images for both the classification and also the detection tasks. The given input will be processed at the backend, then it will be fed with the train model for classification and also for the detection. And finally, outcome will be displayed in the front end. So this is how we have implemented the project. So coming to the algorithms used, these are the algorithms used in the project. So these are the algorithms used. We have used Darknet 19, Inception v3, ResNet 101, DenseNet 169, MobileNet v2, VGG16, GoogleNet, ShuffleNet, SqueezeNet. And in the DNN Findwell model, here we have combined all the three models, that is Darknet 19, Inception v3, and ResNet 101, which combinedly makes an ensemble model. And we extracted features using Relief, and we have implemented KNN. As an extension, we have incorporated the exception model, which performed well. So we have used it for deploying it in the front end to detect the kidney stones. And the other part of extension is detection. For detection, we have implemented all these versions of the YOLO. Moving on to requirements. To implement this project, we need hardware and also software requirements. Coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now, let us execute. To execute, we need to open the code folder which contains source code files. Let us open the code folder. So here we have two subfolders and one file. So first, let us open this application folder. Here we have first sample folder. Let us open it. Here we have two more subfolders. So the images which are present in the classification folder that we will be using for the front end classification of kidney stone disease. And here we will be using the images which are in the detection folder for detecting kidney stones in the front end. So these images which are present in this we will be using as the test cases. Coming to static folder. In this folder, we have CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. Coming to templates, in this folder, we have HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have best.pt file. So this is the model file that contains the algorithm information. This will be loaded into the project code during runtime. This is the signup.db file. This file is a database file which is used to store the user information. And here we have two more model files. This file is for detection purpose and these two files are for the classification purpose. Let's get back. Coming to the notebook folder. Here in this folder, we have the dataset used. And also we have the datasets in the other folders also. In the overview, we mentioned that we have used two datasets, right? So these are the two datasets that we have used. So coming to CT kidney, here we have CT images of the kidneys. Here we have three subfolders, normal and stone. Let us open the normal folder first. So these are the images of the kidneys. So these are the CT images. Here we have kidney images, CT kidney images where there is stone present in the kidneys. Let's get back. So these two folders are combined and saved as train and validation, where we will be using train folder to train the model so that they will be able to classify the kidney stone. And here in the validation folder, we have the images that will be used to evaluate the train models. So let's get back. Similarly, we have in the other dataset folder also. So here, if you observe, we have train and test folder. The images which are in train used to train the models, and the images which are in test, they are used to test the models. Let's get back. So images which are present in both the folders are used for classification. And coming to the detection, images are present in these three folders. Let us open this folder first. So here we have two more subfolders. One is train and the other one is valid. Let us open the train. Here we have two more subfolders. One is images and the labels. Let us open images. So these are the images used to train the YOLO models for the detection of kidney stones. So these are the images used for detection purpose. Let us open one. So images are this kind of images. Let's get back. Let us open the labels folder. Here we have files containing annotations or labels for objects in the corresponding images. So these label files they contain the object locations in the corresponding images. For example, here each file is a label file that corresponds to an image file in the images folder. So this file corresponds to the first image of the image folder. It corresponds to this. Similarly, for the second, third, fourth, accordingly, for all the 1183 images, we have corresponding 1183 label files, which provide the object locations and classes. Let us open one file. So here, these these label files they follow the YOLO format. So this is the object class index, and here it is followed by its bounding box coordinates. This is the x limit, this is the y limit, this is the width, and this is the height. Similarly, we will be having in all the 1183 label files. Let's get back. So images which are in the train folder are used to train the models, and validation folder is to evaluate the YOLO models. Let's get back. Similarly, we do have same images in the YOLO V8 and YOLO V9 folder, but they are annotated differently because each YOLO version requires its own specific type of annotations for training and testing the models effectively. Having separate folders helps keeping the dataset organized, ensures that each YOLO version receives the correct annotation it needs to function properly. And here we have two notebook files. Here we have total three notebook files. These are the Jupyter notebook files. Just a minute. So here we have three notebook files. These are the Jupyter Notebook files, which have the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So here in this two files, we have the models trained for classification purpose. Here in this Jupyter Notebook file, we have the models used to train for detection purpose. Let's get back. Now we have to execute. To execute, open the application folder, copy the path. Now, so here if you observe, current directory is changed to the code folders path. So by giving the cd command, current directory will be changed to the code folders path. Now we have to compile the app.py file by giving the command python space app.py. Now click on enter. So what will this command do? So this command, it will execute the Python script and perform a runtime check for any syntax errors or logical issues. And after running this app.py file, Flask framework, it will host the application that to locate the default address. That is the local host and the port unless configured differently. So here we will be getting the link where the application will be hosted. Just wait for a while. And here we got the link. So this is the local host and the port where the application has been hosted. Now copy this local link provided by the Flask framework and paste it in any web browser. I've copied the link. Now you can paste it in any web browser. I prefer Google Chrome, so I will be pasting here. Here I've pasted the link. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So now register, click on register and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on did you add an account? Give your username and the password. Click on login. We have logged in successfully and we are redirected to classification and detection page of the project. As we're using two data sets for classification, we will be using both the data sets for classification. That means we will be using test cases of KD1 to classify the chronic kidney and KD2 also for classifying the kidney stones. And then we will be doing the kidney stone detection. So first let us use the KD1 of classification. So click on that. Here you can see choose file button, right? We need to click on that for uploading the images of CT images. So let's click on that. So click on choose file. Open the sample folder as we have test cases in it. As we're doing classification, open classification. Now we are doing classification using KD1, so open KD1 folder. Let's upload the normal images first where there is no kidney stone in it and see whether the application will correctly predict or not. So let us upload the second one. Click on open and now upload it. So here we got the prediction. Images processed at the backend and then train model gave us the prediction. So here we got the prediction that patient is not diagnosed with kidney stone in CT image. Here's normal. That means that this is the image uploaded. From the image, the algorithm has observed that there is no kidney stone in it. Let's try uploading some more images. Click on choose file. So now let's upload this image. Click on open and now upload it. So based on the uploaded image, here we got the prediction that patient is not diagnosed with kidney stone, is normal. Now let's upload the other class. Click on choose file. Open the stone folder. So now let's upload this one. This is the uploaded image and here we got prediction correctly that patient is diagnosed with kidney stone and he has kidney stone after observing it in the CT image. Let's try uploading two more images. Click on choose file. So now let's upload this image. Click on open. Click on upload. So this is the uploaded image and here we got the prediction that patient is diagnosed with kidney stone in CT image. Let's try uploading last image from this data set. So let's upload this image and now upload it. And this is the uploaded one. Here we have the prediction that patient has kidney stones in their kidney. Now let's do classification using KD2 in which we have CXR images. Open KD2. Let's upload the kidney stone images and see whether the application will correctly predict or not. Let's upload this one. Click on open and now upload it. So this is the uploaded image and here we have the prediction that patient is diagnosed with kidney stone in CXR image. So this is the CXR images that we have uploaded and here we have the prediction that there is kidney stone in his kidneys. Now let us upload two more images from the same data set. Let's upload this one. Click on open and now upload it. So this is the uploaded image, and here we have the prediction that kidney stone is diagnosed. There is kidney stone detected in the kidneys. Let us upload one more. So now let's upload this one. So after uploading the image, here we got the prediction that there is kidney stone detected in the diagnosed in this CXR image. Let's upload the normal images from the same data set. Open the KD2, open the normal folder. So now let's upload this image. Click on open and now upload it. So based on the uploaded image, here we got the prediction correctly that normal, it is normal. That means there is no kidney stone in the kidneys. Let's try uploading last image for classification. So now let's upload this image. So here also we got the prediction that there is no kidney stone in the kidneys. It is normal. Now let's do detection. Click on detection. Click on choose file. So open the detection folder. These are the images need to be uploaded. So let's upload this image. Click on open and now upload it. Here if you observe, the application has correctly detected the normal. That means there are no kidney stones in the kidneys. This is the chest X-ray uploaded, sorry, CT image uploaded of kidneys. Here it has correctly detected as normal. And it has given a probability score that 0.76. It is nothing but the probability score, that is how confident it is in detecting this class normal. Let's try uploading some more images. Click on choose file. So now let's upload this image. Click on open and now upload it. As there are no kidney stones here, so here we have the normal detection. That means it has drawn a bounding box around the kidney and given it as normal, as there are no kidney stones. Let's try uploading some more. Now let's upload this image. Click on open and now upload it. So here one kidney stone is detected and a blue color bounding box is drawn around it with the 0.59 probability score. Let's upload some more. Now let's upload this one. So this is the uploaded image, and here stone has been detected. Here if you observe, stone has been detected. Now let's get back. Click on choose file to upload one more image. Let's upload this one. Click on open and now upload it. Here a stone has been detected in the kidneys. So this is the image that we have uploaded, and here is the area where stone has been detected. Now let's try to understand what is the difference between classification and detection, because from starting itself we are hearing the term called classification and detection, right? Now I will explain you difference through this test cases. So let's upload one case of classification. Click on choose file. Let's upload this image. Click on open and now upload it. Here, when we do classification, classification is just looking at the picture and deciding what it is. So here we have seen the picture, and here application is classifying. It is just classifying what is this picture. So it is deciding that there is no kidney stone in the picture. Similarly, coming to this detection part, now if we click on choose file, let's upload image. Let's upload this image. So let's upload this image. Click on open, click on upload. So when it comes to detection part, it is not only about figuring out what is in the image, it is about finding out where it is. Here it is classifying as there is stone in the kidney, and it is also drawing a bounding box around that kidney stone. So when it comes to classification, it will only just decide what it is. So when we come to detection, it will highlight the area where is that object present. Now you got clarity, right? What is difference between classification and detection? So now let's check with the graphs. Click on graph. So here, all the algorithms are trained on the KD1 dataset where we have CT images. So these are the algorithms used to train the model so that it will be able to classify whether the person has kidney stone or not from the CT images. This is the accuracy comparison graph where on x-axis we have accuracy score and on y-axis we have algorithm names. This is the precision score comparison graph. Here we have recall score, we have FN score. Recall, precision, FN score and accuracy are the error metrics used to evaluate the classification models. Coming to KD2, here we have trained all the algorithms on the KD2 dataset in which we have CXR images. So this is the accuracy comparison graph. Here if you observe, exception model is having the highest accuracy. Similarly for KD1 is also exception model is having the highest accuracy. So here we have recall, FN score. Coming to the detection part, here we have confusion matrix. So this is the confusion matrix where on x-axis we have true class and on y-axis we have predicted class. This is the FN score, that is F1 confidence curve graph where on x-axis we have confidence and on y-axis we have FN score. And this is the precision recall curve graph. Here on x-axis we have recall score and on y-axis we have precision. So here we have precision score graph. Here on x-axis we have precision score and on y-axis we have all the algorithms. These are the different versions of the YOLO used to train the model so that they will be able to detect the kidney stone from the image. Here we have recall and here we have MAP. So here MAP, recall and precision are the evaluation metrics used to evaluate the detection. Accuracy, precision, recall and FN score are for evaluating the classification. Precision, recall and mean average precision, that is nothing but MAP, is used to evaluate the detection models. So now let's log out. Click on log out. In this way, just by uploading CT images or CXR images to the system, it will be able to classify if you want to just classify. If you want to detect, if you want to know where that particular stone is in the kidneys, you can use the option of detection, which is the extension part of this project. By this, patient will be helpful, he will be benefited, and also the doctor will be benefited to do the diagnosis earlier stages itself. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.